Okay, sorry, I forgot to put this. Okay, x to the power of 3 divide by 3, okay, minus alpha x, okay, plus 1. So I want to know what is the value of x. In this case, I use CALC. As you can see, CALC on your calculator. So the calculator asks you what is the x. So I put the negative 2. So I get 1 over 3 or 0.333. Okay. If let's say I forgot to put negative 2. Sorry, negative 2. Negative 2 is supposed to be x to the power of 3. I missed sorry. My equation that I put is wrong. Sorry. So I have to repeat again. So I start all over again, okay? Alpha x to the power of 3 divide by 3, okay? Minus alpha x to the power of 2 plus 1. So find CLC, negative 2. So I get negative 5.6667 in 4 decimal places. Then again CALC, and they ask you for next x. So I put negative 1 and got negative 0.333. Okay, press CALC, press 0, you will get 1. Press another CALC, you put 1, you will get 0.3333 and so on. Okay, all right, so far any questions so far? So I applying CALC, just applying CALC to find the value of this. Okay, all right, so this is the fx when you substitute the negative 2, negative 1, 0 and so on. Okay, so by applying intermediate value theorem, okay, so we find that the sign for each value, this is negative, negative, positive. For by using intermediate value theorem, they say that if if there is a different sign, for example, here we have negative value and positive value, then this is actually the different sign. So there exists one solution will be occur in the interval of negative 1 to 0. Okay, and next you find positive here, so there is no solution here. So positive, negative, the one solution will be occur in this interval, which is 1 2. 1 2 is from here. Be careful, the interval is based on the value of x, it's not the value of fx. Okay guys, I repeat, positive, minus, so different signs, so there exists a solution between interval 1 2. Okay, and then there is one more interval will be occur, there is one more solution will be occur in where there is different sign, negative and positive. So there is one more solution occur between 2 and 3. So if I ask you, determine whether a solution exists for the fx in the interval negative 2 and 3, so you should say yes, there are 3 possible solution will be exist, which is in the interval negative 1 0, 1 2 and interval 2 3. Okay, because there is different sign for interval negative 1 and 0, different sign of fx. Okay, and it also has been proved by this graph. This graph, okay, I sketch using Desmos. Okay, you can use your handphone, your laptop to find Desmos. Okay, Desmos.calculator. Okay, I'm not going to switch my screen because I afraid you will confuse. You can find Desmos graphing calculator. You can key in the equation x cubed over 3 minus x squared plus 1, and you get this graph. And you can see there is one solution here. Sorry, I may change the color of the pen. Okay, one solution here, one solution here, one solution here. Solution when the fx equal to 0. Here is the x-axis. This is the x-axis. Okay. Here is the x-axis. Here is the fx-axis. Then when the fx equal to 0, meaning that its intersect at x equal to 0. So there are three solutions, which is occur at from interval -1 to 0. Okay, and then occur in the interval 1 to 2, and one more occur from in between interval 2 to 3. Okay, so the graph has proved that the interval that we obtained are correct. Okay, all right, so far any question? This is about the intermediate value theorem, and we are going to apply this theorem for the bisection method. Okay. Okay, if you don't have any question, I will proceed for bisection method. Okay, you are free to interrupt me during the session if you have any question. Okay, all right. So bisection method, again, you have to remember we want to know the value of x so that the fx equal to 0. Okay, but there is possibility that you have to do calculation up to the condition given. Okay, I will explain you later on. Okay, so again, I always advise students to fix the decimal points. Okay, in this case, we are going to find the solution of exponential negative x minus x in the interval 0 to 1. Okay, you have to remember for bisection method, we need an interval. We need an interval to start your calculation. Okay, so this interval, this one will be the value of a, this one the first interval will be value of a, this is value of b. Okay, a and b. So as you can see, I have a table here. This is a, this is b. Okay, so before start the interval, the calculation, you have to make sure you have this interval. If you don't have this interval, you have to find it. Okay, all right, let's proceed. All right, so the given in the question that you have to use 3 decimal places. Okay, so we fix the decimal points for you. Okay, this is easy for you. If you fix the decimal point, it's easy for you to you can avoid to make the round out, because some students quite confused in round out the values. Okay, for example, you get 0.34678. Okay, we want 2 decimal places. So some students very not sure how to round out the value. So by using this apps, you fix the decimal point, so you don't have to do the round out. The calculator will do for you. Okay, all right. So we already put the value of a, B, and this is the midpoint. I hope everyone still remember what your lecturer have teach you. The midpoint, you have to remember the bisection point. The concept of bisection point is actually you want to increase. You want to make the interval smaller and smaller until the value converge to the solution. So the initial interval is 0, 1. Okay, so the midpoint is 0.5, where a plus b divided by 2. So here FA, FB, FC is are finding by using CALC. Okay, so now you can use your calculator. Okay, all right. In this case, my calculator that I use on my screen have to use this. Okay, exponential negative x, okay, minus x. Okay, so I press the CLC. So find the value of fx when x equal to 0. So I get 1. So this is the 1. Okay, and then CALC again, I press 1. I get negative 0.632. Okay, and then I put CLC again 0.5. Okay, and then I got negative 0.107. Here I forgot to change the decimal point, fix it just now. It's supposed to be 3 decimal places, but now I use 4 decimal places, but it is no issue at all. Okay, so this is the full solution. Okay, let me change the decimal points. Let's say we want to use 3. Okay, now I have 0.107. Okay, all right. 107 negative 0.60. Okay, you need to continue the calculation of bisection. In this case, if you read the question, there is no additional information given. There is no additional condition given. Meaning that you have to find the solution until the fx equal to 0. Okay, but initially you have the interval 0, 1 to continue your calculation. To continue your iteration, you have to have a new iteration. Okay, a new initial value, a new value, which is here. Initially you got 0, 1, and next value, the new a and new b should be fine. Okay, so now you are going to use the intermediate value theorem. So FA, you have to check whether FAFC or FBFC. Okay, FAFC or FBFC. Be careful, guys. Please remember FAFC or FBFC. It is impossible for you to check FAFB. If you use FAFB, meaning that you will use the same uh, A and B for the next iteration. So you have to be careful. It has to be FAFC or FBFC. So check FAFC. In this case, A is positive, FC is positive, so it's not satisfied the intermediate value theorem. So you have to check FB and FC. So FB, FC have different sign, meaning that it satisfied the intermediate value theorem. Then FB, FC, then B will be remain, C will replace the value of A. Okay, let me write here. B will remain because the FB, FC is satisfied. So B is remain. Okay, B is remain, then C will be replace the value of A. Okay, now we continue, find the midpoint, and this value, next the value will be found by using CLC. CLC as I showed before, so you use the same fx. Now you check FAFC. Yes, it satisfied the intermediate value theorem because here is FA is positive, FC is negative, then A is remain, the C will replace the B. Okay, this is for I believe most of you already understand this process, so I'm not going to go in detail how to do this, but you have to understand, you have to remember how to compare, how to get the value. It has to be FAFC or FBFC. Okay, so if let's say FAFC is satisfied the condition, meaning that A will be A, B will be C. If let's say FBFC is satisfied, then B will remain, A will be C. Okay, all right. So you can go through this process by your own. Okay, and you have to stop when the FC equal to 0. So the solution that you want is 0.567, the C here. Okay, remember guys, you have to stop when the FC equal to 0. Then the solution that you want is this one, 0.567. Okay, all right. So the important thing in the bisection method is, first thing first, you have to know that it has to be to start the bisection, you have to have the interval. Okay, to be the value of A and B, and C is the midpoint, and then FB, FA, FB, FC you can find by using CALC as I showed you to you just now. And how to check the sign, you have to be very careful. It is actually not difficult, but you have to be very careful. Okay, All right. If let's say both condition not satisfied, in let's say you calculate but both condition not satisfied, you have to redo your calculation because there is no it is impossible that both condition not satisfied. There is possibility that your calculation make mistake. Okay. All right. Okay. So far, no question. Is there any question? Am I too fast? Okay.
Oh, okay, okay.
All right, very good. Okay. So now I proceed if to another example. I have now x to the power of 4 minus x minus 10. For this question, there is additional information given, which is tolerant value. This which is called as tolerance value or convergence value. Okay. It's denoted as value of epsilon. As you can see, epsilon. We call this as the epsilon. Epsilon. Okay. The term here is actually tolerance. Okay. If there is additional information given like this in the bisection method, what you have to do is your calculation will stop when the epsilon, which is the value of A minus C or B minus C is equal to 0.015 or less than 0.015. Okay. All right. So let me give explanation again. Okay. For this case, your initial interval is 1.5 and 2. Okay. You find C, you find FA, FB, FC. You have to check A minus C. A minus C or B minus C. Okay, you have to check this value. And this value, if let's say it is not equal or less than 0.015, so you need to continue. Okay, for example, here we get 0.25. How we get 0.25? 1.5 minus 1.75. There is absolute value here, meaning that the value is always positive. Okay, you can use your calculator now. You can check by your own. 1.5 minus 1.75 or 2 minus 1.75. The value will be same because 1.75 is the midpoint. Here is 1.5, here is 2. So this is actually has to be same. So you get the 0.25, which is not satisfied the value of epsilon yet. So we need to continue the iteration. So to continue the iteration, we need the new A, we need the new B. Okay, so how to get the new A and the new B? You need to check the sign as we have discussed before according to the intermediate value theorem. So in this case, we check FA, FC, no different sign. So we check FB, FC, FB, FC. FB, FC, positive, negative. So FB, FC, then B remain, C will be replace the value of A. Okay, B, C, then B remain. I repeat, B remain, C will replace the value of A. Then we continue. You have to calculate the value of A minus C. Okay, if it is still not satisfied the tolerance value, you continue again until, as you can see at iteration 4, when I calculate the value of A minus C, when I calculate A minus C, I got 0.015, then I can stop. Okay, so my iteration can stop at when I get the epsilon value 0.015. Okay, so we consider that the solution that we want is this one. This is the solution. All right, understand? So according to example 1 and example 2, I can conclude that for bisection method, okay, for bisection method, stop the calculation or iteration when there are two conditions. First, if FC is approximately equal to 0 or equal to 0, or if the tolerance when the A minus C less or equal to the epsilon, or B minus C less than equal to epsilon, which is the tolerance value. Tolerance value. Okay, the term here is the tolerance value. Okay, where the epsilon, the value, the tolerance value given in the question. Okay, there are two conditions to stop the calculation of bisection, whether if you get the FC approximately equal to 0, or if let's say the A minus C, if let's say you are given additional information in additional condition, which is value of tolerance, okay, epsilon in this case, the A minus C less or equal to epsilon, or B minus C less than equal to epsilon, then you can stop the iteration. Okay, you can stop the calculation. Okay, any questions so far? Okay, so for the first method, we have learned how to use the CALC, and the second one, and some information on how to stop the iteration, how to stop the calculation, and also about the intermediate value theorem. Okay, how to apply intermediate value theorem in the bisection method. Okay, so far, no question? Everything is clear? Okay, I hope everyone clear with my explanation. Okay, you may ask, no worry, you may ask me if you're not clear, okay? Okay, let's move to next method, Newton-Raphson method. Okay, we also use this Newton-Raphson method to find the initial value, to find the solution of the fx. Okay, for Newton-Raphson and secant method, these two methods has their own formula. In the exam, we will provide you the formula. Okay, you don't have to memorize because we provide the formula completely. Okay, so the formula for Newton-Raphson is xi plus 1 equal to xi minus fx over f prime x. Okay, over f prime x. Okay, you can see there is prime here, meaning that you have to do the differentiation if the differentiation value is not given for you. Okay, let's move to the first example. Hopefully everyone clear with the information given in the slide. We are going to solve the x cubed minus 4x minus 9 using Newton-Raphson method, and the initial value is given x0 equal to 2. Use for decimal places in your calculation. Okay, so I'm going to use the calculator directly. Okay, I'm going to use the calculator directly. So first thing first, we fix the decimal points. So decimal points required by question is 4 decimal points. Okay, then second thing is you have to make sure you have differentiate the fx. The fx given in the question is x cubed minus 4x minus 9. Some question give you, provide you the differentiation f prime. But if it is not given in the question, you have to do the differentiation. Okay, for in this case, we have x cubed minus 4x minus 9. So differentiate it, you get 3x squared minus 4. I hope everyone clear with the differentiation. Why we did the differentiation? Because formula required the differentiation. Okay, all right. So first thing, you have to have the initial value. Okay, second thing, we have differentiate the fx, we get the f prime x. Now we move to the calculator. Okay, fix the decimal points. The decimal point stated in the question is 4 decimal points. So I fixed the decimal point just now to 4 decimal point. Now first thing first, I will key in the initial value. Initial value x0 is 2. Okay, put 2, press equal. Okay, key in 2, press equal, and press ans. Okay, I hope everyone can follow. You everyone got your calculator in front of you. You press 2. 2 is the initial value. You press equal and you press ans. Okay, I repeat. You press 2 initial value. You press equal and then you press ans. Okay. Okay, now ans. Now we're going to apply the formula. Ans minus. Okay. This is the formula. As you can see, this is the formula. Xi plus 1, Xi plus 1 equal to Xi minus Fxi over F prime Xi. So we replace the Xi to ans. So ans minus F ans over F prime ans. So in this case, ans, just press ans minus. So I use bracket, okay, to separate the numerator and the denominator, and then ans to the power of 3, which is the function of fx. The function of fx given in the question is x cubed minus 4x minus 9. Okay, the f prime, sorry, let me write here, again, sorry. So ans is the ans, okay, ans minus, so the fx is the x cubed minus 4x minus 9 over the f prime, which is the 3x squared minus 4. But now the x will be replaced by ans. Ans here will be ans. Okay, here will be ans, ans. So ans to the power of 3 minus 4 ans minus 9, close the bracket. Okay, as you can see, I already write here. Okay, divide. Okay, open the bracket. 3 ans to the power of 2 minus 4. Close the bracket. It's according to this. Okay. Ans minus bracket, close, open bracket and close bracket for the function, divide by the f prime, which is all the x will be replaced by ans. Then you just press. Is it everyone clear with this? Do you have any problem? Okay, good. Okay, then just press equal. You get 3.1250. Okay, we get 3.1250. Then 2, you just press equal. You get 2.7685. You press more equal. You will get 2.7082. Press equal, you will get 2.7065. Press another equal and you get the same value. Okay, you press another equal, you get the same value. How many equal you press, you will get the same value, meaning that this is the solution that you want. Okay, it is very easy. Just one time put the equation and just use ans. Put the equation in the formula. Just press ans. Just use ans to replace the x, and just press equal sign, equal until it converges to the same value. That the same value will be the solution that you want. Okay. Question, please. I hope everyone can follow. Any questions so far? Any question? Any question?
All good, doctor.
No question. Clear? Everything clear? Everything good? Boleh faham? Okay, very good. Okay. All right, very good. Okay. So, if no question, allow me to move to the next example. Is it okay? Okay, now. I want everyone to try by your own. The method that I show you just now, okay, for this question. We have x squared minus 4x plus 6, okay. So the initial value is 2, so meaning that I equal to I0 is equal to 2, so we're going to find this value and so on until get the solution. So it will be the starting value x1 will be ans minus the ans power of 2 minus 4 ans plus 6 divided by the differentiation of the x squared will be 2 ans minus 4, because the fx is equal to x squared plus minus 4x plus 6, then the f prime x will be 2x minus 4. Okay, so this will be here and this will be the denominator. Okay, so now put in your calculator to get the next value of 1. The x1, I want to hear from you. What is the value that you obtain? Anyone? Just use your calculator. What is the value that you obtain? Anyone? You can type on the chat box. Come on. Your initial value is 0, 0 equal. Sorry, we use the 3 decimal places. 6, 3 decimal places. Okay, we put 0 equal ans minus the ans power of 2 minus 4 ans plus 6 divided by 2 ans minus 4, and then equal minus 4 plus 6. So 2x minus 4 plus 6. 4x plus 6, x squared 2x. I think this calculator got problem. Minus 2x minus 2x minus 4. 2x minus 4. And then equal. What's supposed you get the value, guys? What's supposed you get the value? What's supposed the value that you should get? Anyone? Anyone, please? What is the value that you should obtain? It is math error, okay? I'm not sure why my calculator, because maybe this is the calculator, the calculator on the install. I'm not sure why it's not obtained the value that I should obtain. Okay, it's supposed to be math error. Everyone got the math error value?
Yes, madam.
Okay.
Yes, madam.
Yes,
Okay,
yes.
it's supposed to be math error. The reason why it is math error, because as you can see, the denominator, which is 2x minus 4, when you substitute the x, which is 2, you get 2 times 2 minus 4, it is equal to 0. Then any value, which is x squared minus 4x plus 6 divided by 0, will give you math error. Okay, so as I mentioned here, so meaning that the solution cannot be found if you use the initial value x equals 0, the initial value equal to 2 in this case. So you need to find another initial value. Okay, you understand what I mean? Okay, I repeat. The Neutron-Raphson can be filled, will be filled if you the initial value put into the f prime give equal to 0. Okay, you have to make sure you choose the correct initial value. If the initial value not suitable for the f prime x give equal to 0, meaning that it's not exist. Okay, the calculation will be not exist, then the Neutron-Raphson will be failed. Okay, so I repeat, the Neutron-Raphson method can fail if the f prime of the initial value is equal to 0 or too close to 0. To 0 or too close to 0. This is a point here. Okay? I'm not sure why my calculator not provide the answer that I want, but if I use this calculator, it will give you math error. Okay? Okay, clear. Is it clear, guys? Okay, yeah, Tunas ask what is the initial value. Initial value for this question is 2. Okay, initial value is 2. Okay, initial value is 2. So you substitute 2 into the f prime, you get equal to 0. Then any value, for in this case, 2 divided by 0 is not exist, then your calculation will be failed. Net Neutron-Raphson will be failed in this case because of unsuitable initial value. Okay? Understand? Boleh? Ya, Tunat? Is it? I am answering your question? Okay, good. Very good. Okay, good. So, more question, please? No question? Right, very good. Okay. Okay. For this next question, read the question. Using Neutron-Raphson method, find the value of x3. Find the value x3 for fx equal to x cubed minus 3x minus 1. Use 4 decimal places in all calculation. In this question, the question provide you the value in this table. They provide you this table where they provide you the initial value, the fx, the f prime x, the the x1, which is negative 0.3333. Sorry, I forgot to reduce it to 4 decimal places, but no worry, as long as more than 4, it's okay. Okay, so fx given, f prime x is given. Now your task to find this value. Okay, you understand or not? Your task is to find the x3, which is I equal to 3, meaning that you have to know this value. So in this case, you have to use the formula and you can directly substitute the value given. Okay, so meaning that you want to know the x3, okay, you have to use x2 minus fx2 divided by f prime x2. So x2 in this case is negative 0.347222 minus fx2 is negative 0.000196 divided by negative f prime is negative 2.638310. Okay, so in this case you don't have to use the calculator. I mean, not calculator, you cannot use, you don't have to use the method that I've shown you before, ans and so on. You can directly give the use the formula because the value is given like this. Okay, to find the value. So in this case, what you get, right? You should get, class, please calculate for me what you should get here. Anyone can please calculate for me what is the value that you should have here? Anyone, please? Negative 0.34722 minus bracket, or you can use this, okay, negative 0.000196 divide negative 2.638310. Okay, got negative 0.347, negative 0.347296, if I'm not mistaken, because I use let's say 3 decimal places. If you use 6 decimal places, just press 6 decimal places, you got negative 0.347296. Okay, 3473. Okay, boleh nakib, no problem. Okay, clear? Understand? In this case, if you are provided this table, how you should do is you just apply the formula like I show you here. Okay, clear? Okay, very good. Any question? No question? Okay, next. No question. We can move to next next method. Okay. All right. Very good. Now is secant method. Okay. This is the formula for secant method. Xi plus 1 equal to xi minus fxi. Xi minus xi minus 1 over fxi minus fxi minus 1. So we're going to use the calculator as well. Okay. If you have the question like this, solve x to the power of 3, okay, minus 4x minus 9 using secant method with initial value x0 equal to 2, x1 equal to 3. Okay, use 4 decimal places in all calculation. Compare secant method and Newton-Raphson method. Newton-Raphson method only required one initial value. Newton-Raphson method only used one initial value, one initial approximation. But secant method, we need two initial value, two initial approximation. Term yang you kena faham. Okay. So now we're going to use the calculator. Okay. What you have to do, first thing first, because they use 4 decimal places, so I'm going to change it to 4 decimal places. Okay, 4 decimal places. All right. So this is the initial value given, x0 equal to 2, x1 equal to 3. So first thing first, we set this to be A, this to be B. Okay, allow me to use this. Okay, I use the next slide. Okay, so this will be A, this will be B. Okay, so we're going to use A and B in your calculator. So this is the formula of secant method. Okay, so we're going to replace the xi to be B. Okay, this will be xi, this will be xi minus 1. Okay, xi, this will be the xi minus 1. So, okay, you understand, okay? This is the formula of secant method. So, xi will be replaced by the B. Xi is, okay, this one is B. Xi minus 1 will be replaced by A. So, this one will be B, this one will be B, this one will be A. So, that's why we get this. Okay? Faham? Clear so far? Is it clear, everyone? Okay. All right, good. Okay, good. So for the starting value, we put 2 as the A, 3 will be B, because 3 is the xi. The previous the value before the xi is xi minus 1 will be A. Okay, so we're going to substitute everything in the calculator. Okay, so first thing first, it is B. Just press this, okay? B, okay? Alpha B, okay? Minus, I use 2 bracket because I want to separate. I use 2 bracket here because I want to separate between numerator and denominator. So here you can see I use 2 bracket. 2 bracket, okay? 1 bracket for everything and another one for the FA. This one, another one for B minus A, okay? So the equation given in the question is the x cube minus 4x minus 9. This is the fx. Okay, so the x will be b, this will be b, this will be b. Okay, so b alpha b to the power of 3 minus 4b minus 9, close the bracket. Okay, close the bracket. Here, close the bracket. Now b minus a, open the bracket, alpha b minus alpha a. Okay, close the bracket. One more bracket to close the numerator. Atas dia tu, this one, to close this part. And then the denominator should be divide. Open the bracket one more. Okay, and then this one. Okay, this one, FB. Okay, FB now. So B alpha B to the power of cube to the power of 3 minus 4B B minus 9, close bracket, minus, now is A. Okay, FA. FA is alpha A to the power of 3, to the power of 3, to the power of 3, sorry, to the power of 3, shift 3. Okay, what's wrong with this one? Okay, shift to the power of 3, okay, minus 4 alpha A minus 9, close bracket, okay. Now you already entered this in your calculator, okay, which is actually equal to this, okay. Then CALC, press CALC, okay, and the calculator asks you what is the value of B. Your V is equal to 3 equal, your A is equal to 2 equal, now you get 2.600 for I equal to 2. Okay, so far any question? Is it okay, class? Any questions so far? Okay, very good. So again, to find the next value, press the CLC, and what is the new B? This is the B, new B, this is the A, the new A. Okay, this one will be the new B, the previous one will be A. B now is 2.600. If you don't put 00, also no problem. Equal, what is the A? Is 3. Equal, so you get 2.6933. Okay, now this one will be B, this one will be A. Press the CALC. What is the current B? It is 2.6933 equal. The current A is 2.600 equal. You got 4 equal to 2.7072. Okay, now this one will be, this value will be B, this value will be A. Just press CALC again until you get the value. The current B is 2.7072 equal, the current A is 2.6933 equal, and you get 2.7065. Now this one will be B, this one will be A. Okay, now you press B, 2.7065 equal, your A now is 2.7072 equal, and you get the same value, which is 2.7065. Now you already reach to the solution because it's already repeat the same value. So this is the solution that we want. Okay, again, I repeat, first thing first, you should understand what is the A, what is the B. Okay, I repeat, we start with this one as A, this one as B. So you put in the calculator, just follow the formula. Okay, this is the original formula. Okay, the A is the xi minus 1, the B is is the xi. So you substitute the formula, the xi is the B of minus FB. This is B minus A, and FB minus FA. So what is the FB? F is the function given in the question. This is the F. Okay, so you substitute, x will become B, 4B minus 9, and so on. Okay, you get the value, you get the new value, you get the new value. Now this one become B, this one become A. Okay, you calculate just CALC, then you will get the new B, the new A. Okay, and so on until you reach the same solution. Okay, so far, do I need to repeat? Is everything clear? Okay, bagus Norain. Banyak sangat tu thumb up tu. Yang lain okay? Other class? Okay, very good. Yeah, tonight okay. Okay, good. All right. So is clear? Everything clear? Okay, so I move to next question. Okay. Now, if you are given this kind of question, using secant method, find the value of x4 for the fx equal to x squared minus 3. You are already given a table like this. You have the xi until I equal to 3. You already have the fxi, and your task is to find x4. Okay, x4. You want to know this value. So no need to use the method that I show you just now. You can directly use the formula. This is the formula of secant method. Check the formula and you can substitute the value in the formula. So x4, look at here everyone. x4, you want to know the x4? So it's supposed to be x. This is x4, so it will be x3 here. So x3 minus fx3 x3 minus x2 divide by, let me write in this proper way, x3 minus, okay, x4, okay, so fx3 minus fx2. So x3 in this case is 1.7273 minus the fx3, it is negative 0.0164. x3 minus x2, 1.7273 minus 1.6667 divide by fx3 negative 0.0164 minus with negative 0.2221. Okay, just use your calculator, plug in the formula, plug in the value in your calculator, and you will get the value of x4. Okay, understand? Boleh? So what is the value supposed to be for x4, guys? Anyone? What is the value of x4? Just referring to the values given in the table, and you apply the formula, plug in the formula, the values that you obtain, that you are given in the table. Okay, come on, what is the value for x4? 1.7225. Everyone agree with this answer? Yeah, Tunaf give answer 1.7225. Does everyone agree? Is it okay? Boleh? Okay? Clear or not? You got the answer, Nakib? Same with this 1.7229 is 225. You got the same answer? Okay? So how many decimal places? I think it's correct. Okay? So we accept this value 1.7225. Okay? All right. So any questions so far? Any question? Okay, very good. All right. All right. So last one. Okay. Now I repeat, bisection method, we need an interval to start the calculation. An interval meaning that two values. Okay. Newton-Raphson just need one initial value. Secant method need two initial values. But now if let's say the initial value is not given in the question, what you have to do is you have to apply the initial value problem. The different sign fx, fa, fb have different sign, then there exists one solution between the interval. Okay, let's check this question. You are asked to solve the 4x cos 2x minus x minus 2. Okay, guys, the question given is in trigonometric function. You can see or not? 4x cos 2x minus x minus 2. If you are given a trigonometric function, you have to use radian in your calculator. You have to use radian mode in your calculator. Radian. Is radian in my calculator? This calculator is not so compatible. Actually, yes, I have radian here. So you just press radian. So there is R in your calculator. Okay, I think this one is very easy for you. Okay, so I start to find the value of fx as I showed before to you. Okay, from 0 to 5, 1, 2, 3 until 5, and we just use CALC and we get this, and we check there is different sign. There is different signs, so there is one solution will occur here. So in between 2, 3, and also different sign here, positive, negative in between 3, 4. So for the interval 0, 5, there are two solution will be occur. Okay, in between interval 2, 3, 2, 3, and also 3, 4. So there are two solutions will be occur in between 0, 5, which is the sub-interval is 2, 3, and also 3, 4. Is it clear? Okay, because there is different sign occur. Clear? Okay, now let's look at one by one. For bisection. Okay, bisection method. For bisection method, as I mentioned before, we will have two solution, meaning that you have to make two table of bisection. Okay, the first table, the solution number 1, the A0 will be 2, the B0 will be 3. Okay, solution number 2, table number 2, the A0 will be 3, the B0 will be 4. You understand what I mean? Okay, let's look at the bisection method all over again. This is the bisection method. So meaning that you have to make two table to come out two solution. So the first solution with initial value 2, 3, and another solution is the initial value is 3, 4. Okay, clear? Bisection method. For second method, for the second method, we also have two solution. For solution number 1, the initial value x0 is equal to 2, x1 equal to 3. For the solution number 2, the second solution, x0 will be 3, x1 will be 4. Okay, so far clear or not what I am talking here? Okay, in order to start your calculation, is it whether you use bisection, secant method or Newton-Raphson method, we have to have the approximation value. You have to have the initial value, the starting value. For bisection, you have to have A0, B0. For secant method, you have to have x0, x1. So this is what we have, we obtain based on this table. Okay, how about this Newton-Raphson method? The Newton-Raphson method. For Newton-Raphson method, as we know, we just need one initial value only. We just need one initial value, but we have two value, 2, 3. So what you have to do is you have to check the value of fx because we want the best initial value. Actually, you can use whether 2 or 3 as the initial value. But if you want to choose the best initial value, okay, the best initial value, okay, the best initial value meaning that you will get the solution faster. Okay, you will get the solution. If you use 2, you will get that solution faster than you use 3, for example. Okay, so you have to check the fx that you have here. Okay, for example, 2 and 3. Okay, for 2, for solution 1, for example, for f2, you get negative 5.229. For f3, you get 10.522. So the best solution is the value of the value that close to the fx equal to 0, because our aim to get the fx equal to 0. We have to remember, we use the Newton-Raphson, we use the secant method, we use the bisection because we want to find the fx equal to 0. We want to find the fx equal to 0. So, of course, to get the solution faster, you have to use the value, you have to choose the initial value that is, when you substitute into fx, it is close to the fx equal to 0. So now you have negative 5, you have 10. So which one is closer to the 0? Of course this one. Okay, of course this one. So in this case, for the solution number 1, x0 equal to 2 is more suitable because it will provide the solution faster than you choose the fx, you choose the initial value equal to 3. You understand or not? Okay, to get the best to choose the best initial value, you have to make sure the fx is close to the 0. So in this case, if you choose 2, the fx is negative 5. If you choose 3, the fx equal to 10. Of course, you choose the 2 because negative 5 and 10, the negative 5 is closer to the 0 compared to 10. Okay, so fx, the initial value should be 2. How about another one? How about another one? 3, 4. 3, 4. 3, 4. Where should I write it? Okay, here. Okay, let's say here. Okay, for the 3, 4. 3, 4. Okay, fx, f3 is equal to 10.522. F4 is equal to negative 6.328. Okay, remember you want to have the fx equal to 0. Of course, you have to choose the initial value which the fx closest to the 0. So, of course, this value should be choose. I mean, the initial value, the best initial value should be chosen is equal to 4. Okay, because if you choose 3, you will involve with a lot of iteration compared to f4. Okay, you understand, guys? Remember, to choose the best initial value for the Newton-Raphson method, you have to choose the value of initial value that when you substitute into fx, it is closest to the fx equal to 0. Okay, is it clear? Is it clear, guys? Okay, the best initial value for the Newton-Raphson method is when the f of initial value is close to 0. Okay, if let's say you have just now you have the f3, you got 10, f4 you get negative 6. So what is the initial value? What is the best initial value? It's supposed to be 4, because negative 6 is closer to the 0 compared to 10. Clear? Understand? Boleh?
Yeah.
Boleh? No question? Okay, all right, very good, very good. Okay, so my last question. Okay, you may answer my question in the chat box. Okay, compared to Newton-Raphson and secant method, which method you will choose to solve this question? Okay, I repeat. Okay. To find the solution of fx equal to 4x cos 2x minus x minus 2 power of 2, which method you more prefer? Okay, Newton-Raphson or secant method? Okay, please write your answer. In order to find the roots for x cos 2x minus x minus 2, you choose Newton-Raphson or you choose secant method in this case. Come on, answer. You may choose anyone, any method, Newton-Raphson or secant method. Come on. No one? No answer? No one to answer this question? Okay, Yanu said Newton-Raphson. Aisha said secant method. Shami said Newton-Raphson. Nora Ain also said Newton-Raphson. Okay. More question, more answer, please. Come on. Okay. If you ask me, I will choose secant method. Okay. Why? The reason why, okay, because I do not have to do differentiation. Because we have fx equal to 4x cos 2x minus x minus 2. It is so difficult for you to do the differentiation in this case. You agree with me? Okay, it is too difficult to find the differentiation of this function fx, because if let's say the differentiation is not given to you, the f prime x is, if the f prime x is not given, then it's so difficult for you to find the fx. So I choose the second method. Okay. However, if the f prime given, if f prime x is given, I will choose Noether-Raphson. Okay, because Noether-Raphson provide less iteration value. Okay, less iteration compared to second method. Okay, so maybe I can conclude here. Okay, Noether-Raphson versus second method. Okay, Noether-Raphson, we have to have differentiation skill. Okay, but required less iteration compared to second method. Compared to second method. Do you agree with me? Okay, as we can see, we solved the same question just now, second method at iteration number 6, but for Noether-Raphson method at iteration number 4. Okay, so second method, Noether-Raphson just get the solution at iteration number 4, but for second method, we required until iteration number 6 to reach the solution. So in this case, Noether-Raphson required less iteration compared to second. However, we have to have the differentiation skill. Okay, second method, we don't have the differentiation skill. Okay, no, not required to do differentiation, but required more iteration to reach the solution compared to Noether-Raphson method. Okay, you get my point? Both have pro and cons. Okay, Noether-Raphson, less iteration, but we need to do the differentiation. Second, more iteration, but we don't have to do differentiation. Okay, all right. So I hope everyone got the point here from the starting of from the beginning of our session until the end of our session. Okay, so before we end, I want you to fill in the Google form here, okay, as the attendance record, because your lecturer want to know whether you attend the class or not, attend this session or not. It's just nothing. We want to check how many students attend this session, because inshallah we will do another session later on for another method. It depends on the number of the what we call participants. Okay, all right. So before we end, do you have any question before we end? I hope everything clear, and I hope everything it will help you to answer quiz 3 next week. Okay, quiz 3 will cover everything that I mentioned today will be asked in the quiz 3. Okay, so please put in your mind, please make sure you understand, please make sure you apply the calculator, because in the quiz, the question more on multiple choice question, more on short answer question. So if you don't have this skill, the calculation skill, it will be hard for you to get this to answer the question in a short time. Okay, all right. So if you don't have any question, make sure you fill in the form. Okay, we can end the session now with Kitab Al-Fatiha, with Tasbih Al-Farah and Surah Al-Asr. Bismillahirrahmanirrahim. Subhanakallahumma asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Al-Asr innal insana lafi khusr illa alladhina amanu wa 'amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr. Thank you everyone.
Thank you, madam.
Welcome.
Thank you.
Sama-sama.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, madam.
Thank you, madam.
Okay.
Excuse me, ma'am. Hello.
Yes, Ruben nak tanya soalan?
Ya, Puan. Yang recording video ni nanti akan post dekat group ke macam mana?
Nanti kita akan bagi.
Okay.
Okay.
Okay, Puan.
So, Ruban, ni so far clear tak?
Clear. Thank you, ma'am.
Thank you, Doctor.